All right, let's talk about linear programming. Which is lines, a bunch of lines. No circles or ellipses. Hopefully we won't have to add 11 and 7. Because apparently some of us can't do that. I'm not going to name names, but it's me. Alright, so linear programming is a way to optimize situations, either to get a maximum or a minimum from a situation. Okay? Linear programming involves something called an objective function. Like, let's say you want to optimize your profit. So you have a function that represents your profit. And then you have all these other little functions that represent your constraints. Like, you have to have this much of something, but you can't order this much of something. But you have to have this. So all of those are constraints. And what you do is you graph all of these functions, all of these constraints, and you see where they intersect, and you test where they intersect in your objective function. And if you're trying to maximize profit, the point where you get the highest value, that's where you maximize your profit. If you're trying to minimize cost, the point where you would get the smallest value would be where you would minimize cost. So basically what we're doing is we're just going to be graphing enough lines that we make a shape, and we have to see where they intersect. I would definitely use your calculator today because they're lines. So you just solve and you figure out which direction to shade it because they are inequalities. And then that gives you like it's called a feasible region, and then you just test your points and see which one gives you the maximum or the minimum, whatever they're talking about. So like, let's say that we're a manufacturer and we would like to maximize our profit. Our profit is equal to 50x plus 70y. So we get $50 for every x that we sell and $75 for every y that we sell. That's our objective function. And our constraints, well, you have to at least produce some, okay? Or you have to at least produce none. You can't produce a negative amount of toys or whatever it is that we're producing, okay? The cost of making them together is going to be at least, it can go up to $12. Let's see. Let me give you one more so we can close this up. Dadgummit. Alright, so x is greater than or equal to 0. We know that's going to be up here, okay? Y is greater than or equal to 0. That's going to be over here. Basically, with these two constraints, we've limited it to just the first quadrant. So really, we have to worry about these two. So what is this one going to look like when I graph it? Well, x plus y is less than or equal to 12. Y is less than or equal to negative x plus 12. I'm going to have a y-intercept of 12 and a slope of negative 1. That I know. So I'm going to graph it. Can't see enough of it. Going to adjust my window. X minimum of 3 is fine. X maximum, I think I'll go up to 20, and I'm going to count by 2's. And I'll go up to 20, and I'll count by 2's. That's a better looking graph. Okay, so that looks something like that. It's beautiful. Now, this one. Now, okay, let's just think about this for a second. If y has to be less than or equal to negative x plus 12, is this going to be, if I shade this, will it shade above or will it shade below? What points are less than or equal to negative x plus 12? Do you remember how to shade stuff? 11. No? You shade what's true. So what makes this true? Does 0, 0 make it true? If I put 0 in for x and 0 in for y, is this a true statement? Is 0 less than 12? Yeah, so this would be shaded below. Trust me, get an idea of where it's going to shade, but don't go crazy with it. You can shade on your calculator too. Once you figure out where it needs to be shaded, you can shade on your calculator. You just go to y equals and come over here and hit enter until that's showing that it's shaded below the line. Alright, let's talk about this one now. This one's going to be a little bit different because I got a negative in it. So on this one I have a negative 2y is greater than or equal to a negative x. Divide by negative 2. What happens to an inequality when you divide by a negative? Flip the sign. So y is greater than or equal to 1/2 x. So that line's going to come through right there. My calculator cannot decide to shade above or below. I have to tell it to shade above or below, okay? But it looks like it's passing through 0, 0, up 1 over 2. So it goes like this. So what point makes these true? Shading above or shading below? Like, let's pick an easy point to test. Let's test this point right here. 1, 2, 3, 4, 5, 6, 7. That's the point 7, 0. Is 0 less than half of 7? Is 0 less than half of 7? Yeah, it is. So we're going to shade below. Isn't that beautiful? All right, everybody with me? So I've got some points here. I know that point 0, 0. I know that point right there is 12, 0. I'm not sure about that point. Can I figure that out using my calculator? Second, intersect. Yep, yep, yep. That's 8, 4. Alright, so now I take these 3 points that I just found and I put it into my profit and figure out which one gives me the most. Well, guess what? It ain't the first one. Does 50 times 0 plus 75 times 0, you think that's going to give me the most money? How about 50 times 12? What is that, 6,000? Better check it, I'm telling you. see? Oh yeah, it is 600. How about 50 times 8 plus 75 times 4? I'm not even going to try. 700. If I want maximum profits, I'm going to make 8 X's and 4 Y's. That would maximize my profit. 8 X's and 4 Y's. What time do we get out of here? Oh, gosh. Yeah, we don't have time to do. So you got one example of those. That's it. But it gives you an idea.